Good day and welcome to One-on-One Maths Private Tutors. Today we are looking at O-Level and IGCSE Computer Science. We continue with the topic Boolean logic. Let's look at this example. A logic circuit can be represented by the following logical expression: A XOR C, or not C, NAND B. Produce a logic circuit and a truth table from the above statement. In this example, we have a connecting logic gate OR. So this OR is our connecting logic gate. So if we produce one half of the circuit from A XOR C, we have an XOR there, and A and C. So this circuit represents A XOR C. The other half will come from not C, NAND B. This is not C being connected to B to a NAND gate. Then these outputs will be connected through an OR gate. So this circuit is not C, NAND B. Now to combine them, we have A, B, C. So C comes over to A, and they are connected to an XOR gate to represent this circuit. Not C connects to the NAND gate B, and these outputs are now taken to an OR gate, and we have our final output X, which is similar to what we have here. For our first circuit, A XOR C, we can call the output P, and not C as our output Q here, and the output of not C, NAND B, as R. The output of every logic gate has to be labeled. And then our final output here, X. So this is P, Q, then R, and then finally X. So we go to our truth table. A, B, C are our inputs from 0, 0, 0, right up to 1, 1, 1. Now the easiest one to do is not C, which is Q. The not simply reverses the input. So for our Q, if we have 0, this will be 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0. For our P, we should use the logic of the XOR. The XOR gate takes two inputs. In this case, it's taking A and C as our inputs. Our output is P 0, 0, 0, 1, 1, 0, 1, 1 as our inputs. The XOR gate will only have a high if the two outputs are different. So here, then 0, 0. So we are considering this column and that column for our P. If it's 0, 0, 0, 0, you will have a 0. 0, 1, we have a 1. 0, 0, we have a 0. 0, 1, we have a 1. 1, 0, we have a 1. 1, 1, we have a 0. 1, 0, we have a 1. 1, 1, we have a 0. Now for our output R, we take the logics of a NAND gate, and our inputs are B and Q, and the output is R. So our inputs can start from 0, 0 to 1, 1. The NAND gate has output 0 when both inputs are 1, otherwise it will have a 1. So we use that logic using B and Q. 0, 1 to be a 1 there. 0, 0, 1 there, 1, 1, 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1, 1, 0, 1, 0, 1. Now, for the final output X, we take the truth table of the OR gate, and our inputs are P and R. The output is X. So P and R can take values from 0, 0 to 1, 1. So the OR gate is high if there is a 1 in the input. So P and R are our inputs. 0, 1 give us a 1, 1, 1 will give us a 1, 0, 0 will give us a 0, 1, 1 will give us a 1, 1, 1 will give us a 1, 0, 1 give us a 1, 1, 0 will give us a 1, 0, 1 will give us a 1. So this is our truth table. Now let's go to example 4. Look at the two truth tables below. In each case, produce a logic expression and the corresponding logic circuit. So to produce the logic statement, we only concern ourselves with the truth table row where the output value is 1. In this case, A is equal to 1 and B is equal to 0, which gives the logic expression A and not B. So when A is high and B is low, that's when we have a high. So A and not B will give us a 1. So the logic circuit, we should have A, B as our input. So we not B, then connect A and not B to an AND gate and our output X there. Now let's look at this truth table, and we should produce a logic expression and the corresponding logic circuit. This time we have two rows where the output is 1. This gives the following logic expressions. So here we have not A and B, not A and B to give us a high. Then we have A and B. So it's either this or that. So these are connected with an OR gate. Either this will give us a high or that will give us a high. So we have our inputs A and B. Then we connect not A and B to an AND gate. So we now have this circuit, not A and B. For A and B, we tap from A before it is noted and take A and B through an AND gate, then connect these two outputs to an OR gate. This is our final output, X. Now we go to this example. Which Boolean expression is represented by the following truth table? We only need to consider those rows where the output is 1, which are these rows. This gives us the following three logic expressions. We have not A and not B and not C. Not A, not B, and not C. Then we have A and not B and not C. A and not B and not C. Then we have A and B and not C. So this or that will give us a high, a 1. So we join these with an OR expression. So we'll say not A and not B and not C, or A and not B and not C, or A and B and not C. So we start with our inputs A, B, and C. For the first circuit, we start with not A and not B. So we not here, we not there. Then we have not A being connected to not B to an AND gate. Then we include and not C. So the output of not A and not B will be connected to not C through an AND gate. Then we go to this circuit. We start with A and not B. So we have A and not B. Then we include not C to this output. This is not C through an AND gate. Then we have the output of A and not B and not C. These are connected with an OR gate. So this output here connected to an OR gate. So we have done these two circuits. Now we want this final circuit, A and B and not C. So we start with A and B. So we take A here and we take B here, put them through an AND gate. This is the output of A and B. Then we take not C and connect it through an AND gate to the output of A and B. So here we take not C and the output of A and B. So this circuit is done. And we connect it to the output of this through an OR gate. So we take this, connect it through an OR gate. Then we have our final output X. So this is our final circuit. Now let's look at this question. Which logic expression is represented by the following truth table? So again, we look at the output and see which one gives us a high or a 1. So we have not A and B and C. And we have A and not B and C. And we have A and B and not C. And we have A and B and C. So where we get a high is here, or here, or here, or here. So we connect these logic statements with an OR. And our final answer is not A and B and C, or A and not B and C, or A and B and not C, or A and B and C. Then we go to 2. Show that your logic expression in part 1 is the same as B and C, or A and C, or A and B. Now for these two statements, this one and this one, to be the same, this statement here should produce the same logic output as this one, which is the output of this. So we create a truth table for this statement. So we have our inputs A, B, and C, which can be 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, up to 1, 1, 1. So from the top, we start with B and C, then A and C, then A and B. Then finally, we work out B and C, or A and C, or A and B. So in the end, this column should be the same as that column. So let's start working it out. B and C. We are looking at these columns. 0 and 0 should give us a 0. 0 and 1 should give us a 0. 1 and 0 should give us a 0. 1 and 1 should give us a 1. 0 and 0 should give us a 0. 0 and 1 should give us a 0. 1 and 0 should give us a 0. 1 and 1 will give us a 1. So that is the column for B and C. For A and C, 0 and 0 should give us 0. 0 and 1 should give us 0. 0 and 0 should give us 0. 0 and 1 should give us a 0. 1 and 0 should give us a 0. 1 and 1 should give us a 1. 1 and 0 should give us a 0. 1 and 1 should give us a 1. Now we go to A and B. A and B are these two columns. 0 and 0 should give us a 0. 0 and 0 should give us a 0. 0 and 1 should give us a 0. 0 and 1 should give us a 0. 1 and 0 should give us a 0. 1 and 0 should give us a 0. 1 and 1 should give us a 1. 1 and 1 should give us a 1. Then we go to this one, B and C, or A and C, or A and B. Now the OR gate will give us a 1 if any one of these is 1, otherwise we'll have a 0. So 0 or 0 or 0 will give us a 0. 0 or 0 or 0 will give us a 0. 0 or 0 or 0 will give us a 0. 1 or 0 or 0 will give us a 1. 0 or 0 or 0 will give us a 0. 0 or 1 or 0 will give us a 1. 0 or 0 or 1 will give us a 1. 1 or 1 or 1 will give us a 1. So this is the truth table. So we compare this final output to this final output. If they are the same, it means the logic expression is in part 1 is the same as this logic expression we have been given. 0, 0, 0, 0, 0, 0, 1, 0, 1, 0, 1, 1, 1, 1, 1, 1. So this is the same. And with that, we come to the end of this section. Thank you.